Good morning, everyone. Siddharth, good morning, beta. Suprabhatam. Thank you, beta. God bless you, Siddharth. I'm starting the class, and today is a very important class. Here you need to write down. I will be exactly decoding most important part of trigonometry, and I'll explain how and in which way this is exactly getting positive and negative beta. The basic concepts of trigonometry and its application, everything I'm going to discuss about it. Okay. So let's start this class. Shall we start the class, please? Ready, everyone? Good morning. Please kindly give your attendance. Just say hi, good morning, whatever is there. Vanakkam, whatever you want to write, please write. Thank you so much, beta. Now look here. First work is in trigonometry. One very important question is coming most of the time. The question is in the axis, the four axis we are going to understand now. We already know that from this point, if any light ray is I'm saying light ray, if any ray is exactly going anti-clockwise direction, it is considered as Siddharth. Good morning. Vanakkam, Siddharth. Payoja, good morning. Sujata, good morning, beta. Technical gaming, good morning, beta. Now look here. When we go anti-clockwise direction, that time theta is considered as positive. Okay. But when we go clockwise direction, this is anti-clockwise, means opposite direction. It is considered as plus. And when it is going opposite direction, it is considered as minus. So this is one rule. One by one, I'm going to decode all the rules and important points about trigonometry today. So when the ray will be from the initial origin, it will shift like this, means anti-clockwise direction. It is considered as positive. And when it will go like this, subtend some angle, it will be considered as good morning, beta. So here it will be considered as negative. Okay, so this is one part. Now always there is a question. Some questions are like they are asking this question that here in the first quadrant we will be writing it as we will start from 0 in radian system. This will be pi by 2. Means if any ray will be exactly subtending angle from 0 to pi by 2, it will be coming in the first quadrant. And this will be coming in the second quadrant. Good morning, Vita. Good morning, Yashmita. Ultra, good morning. Now, beta, here it is second quadrant, this is third quadrant, and this is fourth quadrant. Now, here it is coming as pi, and here it is coming as 3 pi by 2. Understood, beta? So, here we are always telling that, fine, here we are writing it as, so any angle I am subtending in this, from the origin side, it will be exactly coming as, from here axis, when we will be exactly, the ray will be drawn from the origin. Understood. And from this, the contact, we are going to get theta here. The angle subtended is theta here. So when the angle subtended is theta, we will say here that this part is exactly 0 to pi. This part is pi by 2 to pi. So we will keep on rotating like this. Understood? Or anywhere we will be taking the ray like that. So now I'm going to go with the basics because that was just simple thing I was explaining. That's nothing. Now look here. First part is when we will be drawing one by one, I'll explain everything. Here, all trigonometric ratios. We know that we have 6 trigonometric ratios. Okay. And the 6 trigonometric ratios are sine theta, its reciprocal is cosecant theta, tan theta, its reciprocal is cot theta, cotangent we are calling it as, and then cos theta, that is cosine, and secant theta, that is secant theta. Yes, class 12 का भी है बेटा. तो साइन एंड बट प्लीज ज्वाइन दिस सेशन, you will definitely be understanding many things. Now look here, sin theta, cosecant theta, tan theta, cotangent theta, cos theta and secant theta. So 100% beta, these are the 6 trigonometric ratios, and it is said that in first quadrant all the 6 trigonometric ratios are positive. In second quadrant, sine theta and cosecant theta is positive. Okay. In third quadrant, if somebody will ask you, you will say that in third quadrant, so this is what beta, this is first quadrant, and this is second quadrant, this is third quadrant, and this is fourth quadrant. Okay. So here we can say that tan theta and cot theta is positive here, and here cos theta and secant theta is positive. But if somebody will say you, good morning beta. Now if somebody will say you, this is positive here, this is positive here, this is positive here, and this is positive here, and they will tell you, kindly mug it out, kindly mug it out, don't trust that person, leave that person as fast as possible. Why? You must ask a question. Good morning, Divya. You must ask a person this question, that this question must come in your mind. Why sine theta and cosecant theta is positive in second quadrant, and tan theta and cot theta, that is cotangent theta, is exactly here positive, and here positive is cos theta. There must be some question and there must be some answer, and it is answerable. Why this is exactly, all trigonometric ratios are positive, all trigonometric ratios are not positive here, only sine theta and cosecant theta, and here tan theta and cot theta and cos and secant. The real reason is very, very important, and you must please remember this one and note down in your note why I am exactly telling about this, because the entire answer of trigonometry and positive and negative lies in their 6 trigonometric ratios graph. Understood? The graph is the key point, and the graph explains many important things. So one by one, I have informed you this. Okay. So I am going to keep it like this. And with this, one by one, I am going to prove you why and where. Good morning, beta. Shubham. So now beta, one by one we are going to do this work, and I'm going to explain you everything one by one. Okay. So now first I'm going to go for sine theta. Usually sine theta is said that it is its function. I'm starting with the function also, f such that r tends to r, from real number to real number. But for its bijection, bijection means when I want it to have inverse, that time it will be having principal domain, as its function will change and its principal domain will lie between minus 90 to plus 90. So this is the domain, and in this domain it will be defined, understood, and its range will be coming as closed interval minus 1 to 1. This is exactly about sine theta. Sine theta is a continuous function. Continuous function. Okay. Next about sine theta, it's minimum and maximum. So if somebody will be asking you about sine theta maximum and minimum value, its range is between minus 1 to plus 1. Its range, hello beta, its range is between minus 1 to plus 1. Its range is between minus 1 to plus 1. We must remember some of the most important point. So first thing is sine theta will be lying between r to r. It's a continuous function. Second important point is its domain, principal domain. Here only its bijection is possible. What is the meaning of bijective? If anybody can answer this question, what is the meaning of, Akshay, good morning beta, what is the meaning of bijection? What is the meaning of bijection? The correct meaning of bijection is 1 1 on 2. So it's 1 1 and on 2 will be possible. So it is considered as bijective function. But for bijection, it can't be that. It is between minus pi by 2 to pi by 2, and its range will be exactly coming between minus 1 to 1. But my answer still is not clear. Why? Because I have not explained one thing. I have not explained a very important point about sine theta, that why sine theta is positive in first quadrant, why sine theta is positive in second quadrant, but why sine theta. Assalamu alaikum. Now look here, beta. Walaikum salam. Now look here. So first, second, third, and fourth, beta. Now look here. When you will be talking about first, second, third, and fourth quadrant, you must remember that first and second quadrant, it is positive, and third and fourth quadrant, you might be seeing that sign is not positive, because I told only positive section. Here tan and here it is positive, and rest of the all trigonometric ratios are negative here. Now I'm going to explain you, and I'm going to start the work beta. Now look here, my first work I'm starting from sine theta graph, and that will be giving you the answer. Evening beta, evening will be physics class. Now look here, shall we start our work please? So now look here, first I'm drawing the graph of sine theta. So when I'm drawing the graph of sine theta, you please see on x-axis and y-axis, because see, what I wrote there, you first understand. Here I said set of real numbers, but a real number is exactly not that one what we are thinking. Here real numbers are radians, understood? The radians with angle, and the radians with angle, fourth quadrant, negative in fourth quadrant. Absolutely correct, beta. So we will be starting that point and write that content. Now look at first radian with angle. This R is radian angles. Understood? त्यूज TYUJ बेटा नेम अगर ठीक से रखेगा ना, मुझे समझ नहीं आया नेम, इसीलिए मैं ले नहीं पाई. So now look here, shall we start beta? So here we know that right now only I have written some preliminaries. What in all preliminaries I have written? Let's check this one out beta. Our preliminaries was, look here, I wrote some very important point. I told that maximum of sine theta is 1 and minimum of sine theta is -1. That's a point to consider. Okay. So maximum of sine theta is 1 and minimum of sine theta is -1. But what is maximum of 1 so sine theta and minimum of sine theta? It's about range. Okay. So here, whenever in function you are writing, this is domain and this is exactly range. So here range is real number. We can write range real number, but for inverse, we can write range as -1 to 1. So beta here I am going to exactly explain this part, that is minus, here it is +1 and this part is considered as -1. Now sine theta graph, how sine theta graph will be coming? Now look here, just your every answer is there in the graph. Now I am going to draw the graph and you just check this one out beta. Now this is the graph of sine theta. Now I am doing all the basic works to explain my point. Here this is 0 and here beta if you will be starting this point, it will be pi by 2 and this is pi and this is 3 pi by 2 and that part is exactly considered. I am just increasing this one. And this section, here also I am writing these points. So here this one and just extending this part. So now what we are going to do here is, this is exactly minus pi by 2 and this is pi and this is 3 pi by 2, all minus, 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 and here it is coming as minus 2 pi beta. So you might have seen that the graph is, Akshay, good morning beta, the range and the domain is infinite to infinite, absolutely beta, but in that system, good morning, I can't take it now. In that system, beta, you must remember one thing. It's not bijective. When you are writing here, inverse is not possible. Now, I want to set my point. Now, I said that first and second quadrant, sign is exactly coming as positive. But in other quadrant, sign is not coming as positive. So, we must have a super answer for that. Now, look here. First you check, graph you check, and graph holds the key point for all the answers. Okay. Now listen beta. Listen, just check this one out. I am drawing this part. Is it above x-axis? You children explain this one. Is it above x-axis? Yes, auntie, it is above x-axis. Check this one out. So between 0 to 90, it is above x-axis. So it is considered as positive. Between 0 to 90, it is above x-axis. So it is considered as positive beta. Understood, Siddharth? Look here, beta. So it is 0 to 90, it is above x-axis, so it is considered as positive. Now beta, second one you see, 90 to 180. 90 to 180 also, it is above x-axis, because I told you now, the domain will be x-axis real number. Good morning, beta. Good morning, Lokesh. Here, my children are, all of you are my children, and one thing is there. No, beta. All of you are my children, and one thing is there, like I need to explain in English, CBSE first, and second is I'm in South, and my children are understanding English or Tamil. Most of them are from Tamil and other languages there. So I have to explain in English. That's my only limitation. Okay, beta. I'm fine, thank you. And this is the only thing. And you all people are mine only. So please understand this. And if you are not understanding, sometimes I'll explain. Okay, beta. But its limitation is this only. So I'm working for all of you, but only one this limitation is I'm having. Okay. Now look here. So beta, positive and positive. So first quadrant is above. The curve is exactly above x-axis. The moment you will go above. So once you are going above x-axis, it is positive and positive. So the moment you went positive, that means what? We got a very important answer. We got the answer that between 0 to 90, between 0 to 90, sign is positive, because its main major graph, which is lying between -1 to 1, it is exactly positive in first quadrant. Understood? It is above x-axis. Okay, beta? It is above x-axis. The second quadrant part, when you are talking about, it is again above x-axis. It is again above x-axis, and here also 90 to 180. Come on, go for it. 90 to 180, because beta, this region is 0 and this is 180, and this is 90 and this is 180. That means first quadrant. In first quadrant we got sign positive because its curve is above x-axis. Second quadrant, sign is positive because its curve is above x-axis. Now we are exactly getting the third correct location. Now we'll go for the next one, beta. Come on, check this one out. So this is the third quadrant between pi to 3 pi by 2. When we talk about the third quadrant and we talk about the fourth quadrant, you are seeing one thing which is very, very important, and that one thing is everything is below x-axis. And below x-axis, the values, whatever angle in radian system you are taking, the value will be all negative. The value will be all negative. So third quadrant and fourth quadrant, sign all values are negative. First, second, above x-axis for sign graph. This is exactly what we have drawn sign graph. First, second, above x-axis, values are positive. Third, fourth quadrant represented by pi to 3 pi by 2 and 3 pi by 2 to 2 pi. Good morning, Shivam. So here 3 pi by 2 to 2 pi, it is exactly below x-axis. So for both the quadrant 3 and quadrant 4, could you please revise? I'll revise it better. So first quadrant, first and second quadrant. First and second quadrant is represented by 0 to 90 and 90 to 180. So first above x-axis, so positive. So usually when we say we are writing one very important point. We are saying that first and second quadrant, sine and cosecant. What is the reciprocal of sine? The reciprocal of sine is cosecant. The topic is beta measurement, trigonometric functions, and in that I am explained. This is live. You can forward back and watch the missed part. Thank you, Siddharth. So now look here, beta. So this is exactly the third and the fourth quadrant. Here it is negative and here it is negative. So we fall into a very important conclusion that first and second quadrant sign is positive, third and fourth quadrant sign is negative. Beta, this is the first conclusion section we have drawn, and now we have got a very super answer. The answer is sine and cosecant is positive in first and second quadrant. But beta, right now I am going to start for another important point. I'm going to prove another thing. sine and cosecant. So cosecant graph also I am going to draw and explain why it is exactly going to be positive. Now cosecant graph we are going to understand. In this only cosecant I am going to draw. So in the cosecant section, we are going to understand one thing. Please understand, sine theta and cosecant theta both are reciprocal of each other. Harshita, good morning, beta. Both are reciprocal of each other. Now, beta, when sine theta you are writing, you will say, auntie, cosecant theta is 1 by sine theta, and sine theta is 1 by cosecant theta. Now, the major key part is coming, beta. Okay, I'll revise it, beta, but it is in that you just go for the 1 second up backward, you will get that point. Just this point, after that you will understand. Now look here, cosecant theta, when you are talking about, it is coming as 1 by sine theta. Now beta, sine theta values we are going to check. So topic in class, all the topics are present in my channel. It is for 12th class also, all the topics I am covering with you. So 1 by sine theta is there. Now please pay attention. Cosecant theta is 1 by sine theta. Just put sine theta value as 0. The moment you will put sine theta value as 0, what you are getting is cosecant theta equal to 1 by 0, means cosecant sine 0 value is 0. So it will become infinity. That means the graph of cosecant is not a continuous function. The graph, you didn't understand beta, cosecant part understand, Siddharth, ki sine theta and cosecant theta are reciprocal of each other. Okay beta. So now when cosecant theta, sine theta will become 0, cosecant, questions also I am doing beta. Now look here, cosecant theta 1 by 0 and 1 by 0 is coming as infinity. 1 by 0 is considered as what beta? 1 by 0 is considered as infinity. That means cosecant is not a continuous function. Sine theta is a continuous function, means its graph is not at all breaking. But since the values of cosecant theta is exactly dependent on sine theta, it will be coming 0 and it will be coming infinity. The moment it is touching infinity, it will become non-continuous curve. It will become non-continuous. Rishabh, good morning, beta. Again, wrong. I'll say, yes, it is wrong. But one time, you just check, it will not be wrong, beta. Now look here. So cosecant 1 by 0 will become infinity. That means what? It is not continuous, but it will be continuous in its domain. Please remember this part. So I will write the domain part of it. In that domain section, cosecant theta will be continuous. Okay. Now let's check this one out. I have explained the preliminaries. I explained one thing, that is cosecant is depending upon sine theta value. Sine theta, cosecant are reciprocal. So let's check this one out, beta. So when I'm going to talk about cosecant theta, let's see. Just check this one out. So cosecant, you see this thing. Answers are here only. Sine theta values lie between -1 to 1, and that is closed one. Let's check this one out. So this is exactly sine. So sine theta values lies between -1 to 1. Now where is cosecant? And cosecant 1, yes, I have teased the domain part also, beta. I have explained everything in the previous classes. So now cosecant. So when we talk about cosecant theta, just check this one out. Its range will be coming from where to where, beta? Its range will be coming from this part. Cosecant is reciprocal of sine. We will write here minus infinity, -1, 1 and infinity. So see how the curve is exactly, how the curve is going to respond and give the value that we will draw. But here you check. So that means one thing we have learned, that sine theta values lies between -1 to 1. Then cosecant theta values lies between -infinity to -1 and 1 to infinity. That means you can say very nicely that whatever angles are there, its value will be lying between -infinity to -1, -1 included, -infinity to -1 included, union 1 to infinity. But there will be no values, lying between, -1 to 1. So this I proved one point. Okay, but beta, still our second point is pending. If you remember, I told in cosecant, Okay, so here in cosecant beta, in cosecant first and second quadrant I told it will be positive. So let's prove this point also now. So I'm going to draw the curve. I'm going to draw union means beta together. Intersection means common. Okay, in simple, when somebody will ask you union means together. So if I'm having two elements, 1 and 2, you are having three elements, 1, 2, 3. Union means 1, 2, 3. Means together we are writing. Now look here, beta. We will be going with this part. Let's start this section. Now this is for cosecant I am drawing. So we came to know that sine is exactly reciprocal of cosecant. Sine domain is exactly set of real number. It is a continuous function. Cosecant is non-continuous. Why it is not continuous? Because its values are totally dependent upon sine theta. Just I'm telling you totally dependent, but it's not like that. Okay, it's not like that. It's not like that because there are other points which is proving its identity. Now here cosecant is between minus infinity to minus 1, 1 to infinity. Now let's check this one out. So this is again between minus 1 to 1. And just now we came to know that its values will never lie between 1 and minus 1. Okay. Now we are going to write all the radians pi by 2, pi, 3 pi by 2 and 2 pi beta. And here it will be Siddharth, Payoja. Are you all understanding beta? Minus pi, minus 3 pi by 2, minus 2 pi beta. Sujata, everyone come on, say quickly beta. This is your understanding or not? So now look here. Now we came to know that whenever sine 0 will be there, it is going as infinity. So 100% every time in the breakage point, if you will draw, these are asymptotic lines. What is the meaning of asymptotic lines, auntie? The meaning of asymptotic lines are those lines which break the curve are called as asymptotic lines. Another important point about asymptotic lines are they will never be touched by the curve. They are curve breakers. Understood? They are curve breakers. Understood? They are curve breakers and they are exactly responsible for breaking the curve. Cos is negative in second quadrant. Yes, beta. Cos will be negative in second quadrant. So shall we draw it now? So our drawing will be 0 to 180. It will come, you see, the value will be reaching at its maximum here. So I rest my case. But now case is not still over. Case is not still over. Yes, this is for 11 beta. Case is not still over. If you see very carefully, here very important points I am going to explain now. This is exactly between 0 to pi by 2. That means 0 to 90. So here 0 to 90 degree, 0 to 90 when we are taking 0 to pi by 2. Can you notice one thing? Again, this is x-axis. The curve between 0 to 90 and 90 to 180, the curve is above x-axis. And here between that 180 to 2 pi, it is below x-axis. And I'm just doing quadrant division right now. I'm just doing quadrant division. And here, when I am doing quadrant division, I'll explain, I'll talk to you bit, I'll talk to all of you. This is positive and this is considered as negative and negative. I rest my case. You look here, between 0 to pi, total between 0 to pi, the curve is not continuous. It is breaking. It is breaking because of the presence of asymptotic line. Why asymptotic line? Because sine and cosecant are reciprocal. Wherever sine value will become 0, cosecant will become infinity. Means its curve will break. The moment its curve is breaking, the story is getting over, children. So here first quadrant and second quadrant. Remember, first quadrant and second quadrant, when we are talking about cosecant value, cosecant is positive, cosecant theta is positive in both first quadrant and second quadrant. Why? Because its curve is above x-axis. Now cosecant theta is negative in third quadrant and fourth quadrant. Why? Because its curve is below x-axis. And beta always must remember this part. Siddharth, are you understanding beta? Everyone, my children, are everybody understanding or not? So here when we are talking about up and down, so I have just proved two trigonometric ratios, and we have proved it, beta, that the first quadrant, second quadrant of sine theta is positive, the first quadrant and second quadrant of cosecant theta is positive, just because of one factor, and that one factor is their respective curve. So every trigonometric ratios are defined in their respective curve. Understood? So the curves are exactly the basic answers. The curves are the, yes beta, Naman. Yes, Lokesh. Now look here, beta, bijective is a different case. I have also explained about bijection. So please understand this. So sine and cosecant, when we are talking about sine and cosecant, Naman, na? So sine and cosecant are exactly what? Positive. And this part I think you have understood. So we will go to the next section. Next section is cos and secant. Now we will be talking about cos and secant. I am going to explain their curve also. So we learned some very important points here. The first important point here is, yes, bijective function graphs. I'm going to take some of the important classes. Okay. Now look here, beta. There are two type of beauty in nature. One should be by brain and one should be by body. The beauty which is by brain should be everlasting. And I believe that all the people are beautiful. Only one thing is there. Beauty by brain should be the one. It should be respectable. Understood, beta? So all of you are beautiful, including me. But all of us has to be beautiful by brain and beautiful by our behavior. That's the most important thing a human should learn. Now look here, beta. First and second, third and fourth, beta. So now four quadrants. Yes, four quadrants. Now we are going to go for the second and third one. Second and third is our cos and secant. Now we are going to talk about cos and secant. Now I'm just removing about sine and cosecant. Now explanation I'm starting with. Now look here, beta. Shall we start it? So now next part we are going to talk about cos theta and we are going to talk about secant theta. We know that cos theta is exactly, it's again we are going to understand about its function. So it will be again R to R. Okay, it will be again R to R, but it is not bijective. When we are talking about cos theta, it is not bijective when it is from R to R. So cos theta is not bijective when it is from R to R. Understood? So now what we are going to do here is from R to R, it is not bijective. So we will convert its bijection. What is the meaning of bijection, beta? Its inverse is possible. Cos theta inverse is possible when it is bijective, beta. Cos theta inverse is positive when it is bijective. So we are going to write for bijection. Please children focus. For bijection it is between 0 to pi and it will be having minimum as -1 and maximum as 1. So can we repeat this one, beta? This is not a case of bijection. Okay. Now this is a case of bijection. In this case of bijection means it is 1 1 and on 2. Means its reverse or its inverse is possible. Okay. So now again we are going to draw for cos theta. But we came to know that cos theta is negative in second quadrant and negative in third quadrant. It is positive in first quadrant and positive in fourth quadrant. So there must be some reason behind it. We are going to search this one out. But most important informations we are going to write about cos theta is its minima. Minima is -1, maxima is 1. So we will write, okay, cos theta minimum is at -1, maximum is at 1. So what we are going to write, beta, here? -1 and 1. Again we are going to color and we are going to say that, okay, including -1 and 1. So only closed interval written, including -1 to 1. So closed interval is exactly written there. So this is cos theta. Cos theta principal domain will be 0 to pi. Cos theta principal domain. But beta, I have explained everything. You will be strong whenever you will be thinking about these cases. All the things will be compiled in your brain and together you can teach anyone. You can say anyone, oh, this is not like this. This is the correct answer is this. But we are learning for giving the perfect answer in mathematics. Okay. So now look here. Shall we go for our next word, beta? So cosecant, now we know that cos theta is exactly reciprocal of secant. So cos theta will be equal to 1 by secant theta. So secant theta will be equal to 1 by cos theta. So that means its reciprocal is there. So 100% secant will not be continuous everywhere. This is the most important. Principal domain means what, beta? Very good question, Payoja, you have asked. Nobody asked this question. Now please remember one thing. Principal domain is that region. Principal domain is that region in which a trigonometric function will be defined. It will not be infinity. First thing, what is the meaning of principal domain? The domain in which a function is defined is called as principal domain. Understood? And in that principal domain, it must be bijective also. Understood? So only all the six trigonometric ratios can have two type of definitions. Understood, beta? First part, when we are discussing about, first part we are talking about, that time we are telling that, okay, graph can be continuous, discontinuous. We are discussing about the overall part of the graph. Understood? So in that beta, we are not talking about its principal section, but the second one is principal domain. So whenever we are discussing about this region, we are talking about its bijection. What is the meaning of bijection? Bijection means its inverse can be possible. Its inverse can be possible. That's a major section. Understood? And the inverse trigonometric function based on principal domain. Payoja, I hope beta you might have understood this question. This is a very important question. Most of the students are not knowing. They'll see their principal domain, principal domain, principal domain. They'll see domain, but they don't know exactly what is the meaning of principal domain and what is the simple meaning of domain. In domain, na, for function it is continuous, not continuous. Who is exactly checking? But where principal domain is there, there is a limitation. Understood, beta? That I will also teach that one. Why? We have a wholesome information means, yes. Okay, you know this. That's super, beta. Now look here. So now, now we are going to go for this part. So now we are going to go for this section and we are going to understand this part. So now secant is again going to be reciprocal. So 100%. Okay, secant is domain. So 100%, sorry, secant is reciprocal of cos. So we are going to go for between -1 to 1 beta. So between -1 to 1, again we are going to do one work. We will be exactly going from here, that is minus infinity. Here please check. So that means if somebody will ask you what is the range of secant, then what decent answer what we are going to give is, okay, it is same like that of sine and cosecant. Okay, but definitely sine and cosecant are, sine and cos are complementary of each other. 90 and 90-degree shift is there. That also I'll teach you. Don't worry. We will, without touching book, we will be understanding the entire story. Okay, now listen. So this part is coming. So if somebody will be asking you what is the range of secant theta, then you will be answering beta minus infinity to -1 closed and then union 1 to infinity. So what is the range of cos? The cos lies between -1 to 1 secant theta. Yes, beta. So here it will be lying between minus infinity to -1, including -1, and 1 to infinity. So this is exactly the range of sine and cos. Now we will draw and explain, because my one question still remains the same. And that question was why, this question is why cos is positive, secant is positive in first and fourth quadrant. So we must have a conclusive answer. Screen is not visible. Oh. Now I'm going to draw for cos and secant. Okay. It is one of our trigonometric ratios. Now look here. We will be drawing. Now understand this one, beta. Board sign, because beta I don't know how to put lights and all. So just how much was possible, I tried to do the arrangement. Oh, please spare with the drawing with this side. I'm having very problem with drawing. Understanding is very good, but drawing part is very, very difficult. Now look here, spare with that one. Now look here. We are going to write about these angles as here 0, and this is pi by 2, this is pi, and this is 3 pi by 2, and this is beta 2 pi. Okay, here also minus pi by 2, here it is minus pi, minus 3 pi by 2, and here if you will join, it is coming as minus pi. Did you got the answer, beta? Did you got the answer? Anaconda returns. Oh, you want to see anaconda returns? Now look here, beta. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. And I explained a very important point about sine cos theta curve. If you will be seeing, can you check this part? Everything is exactly about axis. If you will see here, please check, this is first quadrant, 0 to pi by 2 is representing first quadrant, pi by 2 to pi is representing second quadrant, and pi to 3 pi by 2 is representing third quadrant, and 3 pi by 2 to 2 pi is representing fourth quadrant. And in that beta, you see the curve of cos, here it is positive in first quadrant, negative in second quadrant, again negative in third quadrant, and then positive in fourth quadrant. So the curve of the graph is the respective answer for all the questions. So if next time somebody will be asking you, you just give this answer. You say that ki yes, sine and cos and all the six trigonometric ratios, all the six trigonometric ratios, values will be positive and negative, not because of any other factor, not because of silver spoon, cup, tea, whatever I am reading. Okay, beta, it is because of one very important part. God bless you, beta. God bless you, kings. Now listen. So here, when we are reading this part, a very important section is coming, that first quadrant and fourth quadrant is above x-axis. The first quadrant and the fourth quadrant is representing which one? 0 to pi by 2 and pi by 3 pi by 2 to 2 pi. So here exactly it is first and the fourth is representing what? First and fourth quadrant. It is above x-axis, so it will be positive. Second and third quadrant value is below x-axis, so it will be negative. So I have explained this part for cos, but you will be saying, Auntie, you have not explained about secant, because secant is still the problem. Understood? Secant still the problem, so we must remember secant part. So let's see, we'll go for the secant section, please. So now I think it is inside that part. Okay, now we will go for the next one. So secant part, I told you there will be no values of secant between -1 to +1. So now we are going to draw this part. So the values of the range is exactly above. Okay, it is exactly 1, and this is -1, and this is 0. Okay, beta, but the most important thing is, can you here notice one very important point? The most important section you can notice here is this one. Please check this one out, beta. This is exactly between -90 to 90, between -90 to 90. So beta, one thing, okay, between the -90 to 90, you see here it is exactly, but one thing I want to say you, cos 90, what is the value of cos 90? You will say, Auntie, the value of cos 90 is 0. Once the value of cos 90 is 0, then what will happen? Sine, sorry, secant will become what? 1 by secant 90 will become what? Secant 90 will become 1 by cos 90. Okay, so it will become 1 by 0 and it is coming as infinity. That means after every pi by 2 interval, after every pi by 2 interval, we will get an asymptotic line. What is an asymptotic line? Asymptotic lines are those lines which are making the curve, understood, and the curve will not touch the asymptotic line till infinity. So it is not going to touch. So we are not going to give a very half answer. We will say that it is not going to touch. That's the most important point. So shall we start our work, beta? It is 0 and here it is coming as pi by 2. So 100% pi by 2, we are going to draw a asymptotic line. So now let's draw an asymptotic line. Now here it is coming as pi and then it is coming as 3 pi by 2 and then here it is 2 pi. Again same thing here beta, after pi, after 90 interval. Can you see that odd section? Pi by 2, 3 pi by 2. Here also again we are going to draw an asymptotic line, that is minus pi by 2. Again we are going to draw, our curve will be looking like the second one. You can continue like this and here it is coming as down. I believe you people must have the basic knowledge. Basic knowledge is not there means everything will be problem, beta. Basic knowledge not there means everything will come as a problem. So beta, can we see this part? We will be only focusing into our work. Now look here, this is this section and then I'm going to continue with the remaining part. I think the curve of the graph explained everything. The curve of the graph explained everything. Again, our answer is coming super. You see here, between 0 to 90, between 0 to 90, this is x-axis now. This is x-axis. The curve is exactly above x-axis. Between 0 to 90, the curve is exactly 0 to 90, it is above x-axis, and the moment it is above x-axis, it will be positive. That's it. It will be positive. Now beta, below x-axis, negative, negative, and here again it is positive. So we learned a very important point. We go left, right. Our curve is the most, good morning Raj. So here, good morning Raj, Chaurasia. So here our curve is the most disciplined one. The curve explains the entire section of the function. Which function? Trigonometric functions. Understood? So here first quadrant positive, fourth quadrant positive. For whom? Cos theta and secant theta. And sine theta, sine theta and cosecant theta, it is first and second quadrant positive, third and fourth quadrant negative. So by the reciprocal section, by asymptote line, everything we came to know today. So nobody can make us fool hereafter. We are exactly going to explain people like this is the real content, and because of that only, so silver spoon cup tea, we don't need to mug up because we have the basis of our graph, and the graph has the disciplined answer for why sine cos is positive and negative. So this is exactly for that. Now tan and cot is there. We must understand about tan and cot also, because the story will be incomplete if we will not touch tan and cot, because tan and cot is having a different function. Now look at it. One simple answer I want to give you today. Please understand this. I was first teaching in competitive platform only, beta. During my college time itself, I started teaching. After coming Chennai only, I stopped everything. Now listen, beta. Yes, beta. JS studies. Thank you so much, beta. Bless you. Now listen. So here we will be exactly going for the last one, that is tan. So when somebody will be talking about tan, I will be understanding one thing, that tan and cot are reciprocal. Tan is reciprocal of cot. But I am understanding how you people are going to understand. And tan is exactly negative in second and third quadrant. No, second and fourth quadrant. Which quadrant? Come on, answer. Second and fourth quadrant, tan is negative. Okay. First, tan theta concept. Yes, second and fourth quadrant, tan is negative. Good morning. First and fourth quadrant, tan is positive. Second and fourth quadrant tan is negative. That's what I said. Okay. Good morning, Nishika. So here first and fourth quadrant or third quadrant, Nishi, first and third quadrant tan is positive. Tan theta is positive. So second quadrant and fourth quadrant tan theta is negative. So if tan theta is negative, its reciprocal will also be negative. Okay, so cotangent is reciprocal of tan theta. In simple way, we'll try to understand it. So here, first and third tan is positive, second and fourth tan is negative. How to write it, please? Please understand one thing. Where sine and cos was continuous everywhere, sine and cos was continuous everywhere, tan is not. From the beginning, you must remember that tan is continuous only in its domain. And I hope now you are understanding what is the meaning of domain. Domain where the function is defined beta, that domain section only we will be containing. So now we will get the point. Please note down this section or write down. For tan theta I am writing. For tan theta, it will be open interval minus, so it will be defined for R to R, but there discontinuous lines will be there. Yes, this basics formula also I am going to teach one by one, one by one. We can't go like that much fast, okay? Then you will only have problem. So here, this is exactly in this part between minus infinity, minus 90 to plus 90 and set of real numbers 100%, tan will be exactly continuous. But I am going to explain about its continuity by drawing. So cot will be exactly reciprocal of tan. So cot function will be between open interval 0 to pi, and it will be also set defined for r. Okay, now I'm just going to draw and explain this why tan is positive in first and fourth quadrant and why it is negative in second and third quadrant. Once we will finish, we will start the formulas also, and basic concepts of angles also I'm going to explain later. So this is first quadrant. When we are talking about first, second, third, fourth, this is x-axis, y-axis. First we will draw the asymptotic lines because the curve will be breaking after every pi by 2. Again here pi by 2 is our limitations. Okay, so here we will go for pi by 2 beta. This is pi by 2. Now here again, sorry, yes, this is pi by 2. This will be 0. Got it? I'm just going to draw it big. And this is minus pi by 2. So if I need to draw, I want to draw like this. Don't allow it to touch it. Yes, sometimes it is losing bit. Adjusting on my own, I have adjusted everything. After so long, I started again with a. I was teaching offline, again started online. Now look here, again we will go like this. So we are seeing one thing for sure. Now let's check this one out. For this one only, this is pi by 2, this is pi, and this is 3 pi by 2. Again it will go like this. Okay, so now please understand this section. Again it will go like this. So please understand this part. So here, when we are talking about, again we are going to the first quadrant. So we understood this part now. Now it is like a usual thing. First quadrant, it is above x-axis. Since first quadrant it is above x-axis, so it is, since I am here, again can you see I am drawing this line. This is second quadrant, pi by 2 to pi, and this is pi to 3 pi by 2, and then again if we will exactly go like this, this is 3 pi by 2 to 2 pi. So our all answers are exactly coming here only. So between 0, this content is exactly 0 to pi. This is positive, this is negative, this is positive, and this is negative. This is about your first quadrant, this is about your second quadrant, this is about your third quadrant, and this is about your fourth quadrant. I rest my case. Wherever above x-axis is positive, wherever below x-axis it is negative. So it is a very disciplined graph whenever you will be drawing this. So you are exactly getting positive and negative. But beta tan principal domain will be open interval minus pi by 2 to pi by 2. That's the most important thing. Now we will be going for cot. Okay, so tan 0 will become infinity for cot. So here asymptotic lines will be drawn at every pi content, pi, 2 pi, 3 pi, like that. Here it is asymptotic lines, so you are drawing at every odd interval, pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, 9 pi by 2, like that you will be drawing. But here whenever you will be drawing, you are drawing between this separate part. So please remember this section. So when you will be drawing at every pi interval, you will be getting an asymptotic line for cot. So now let's see, where tan is an increasing function. Another important point I'm just explaining you, in future it will be very helpful. When tan is increasing, cotangent is decreasing. Okay, that's another important point to be noted. So one by one I'll explain everything. So it is 0 and this is pi by 2 and this is pi. Okay beta, now here again I'm going to draw. This is exactly, wait, my curve is dancing up and down. Yes. Pi, here it is coming as beta 3 pi by 2 and it is coming as 2 pi. I hope everybody understood. I hope everybody understood. Now look here beta, when you will be drawing this, I have told you now it is exactly positive and negative. We will be talking about the quadrant, but first can we see this? I rest my case with it. The story ends here only. Because the moment you will be drawing this, you will shut everyone's mouth and you will say that, please kindly see this part. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So in first quadrant, when you are going, please check this one out. This is first quadrant, this is second quadrant, this is third quadrant, and this is fourth quadrant. So here in first quadrant, cotangent is positive, negative, positive, and negative. So negative. So positive, negative, positive, negative. Yes, because the full video is there. So we are in the last part of six trigonometric ratios. Here you just learn one thing: the tan and cotangent is positive and negative in their domain, defined domain, open interval, because of asymptotic lines. They are not continuous. They are only continuous in their domain. So I hope that part that person was telling, like first I think some student asked me that auntie it is not correct. Now I hope you might have understood that it is correct, and the asymptotic lines will break everything. The asymptotic lines will break everything, break every curve. So sine and cos are the only two trigonometric ratios which are continuous. But rest other than that, all the four trigonometric ratios are negative. Understood? All the other four trigonometric ratios will be, sorry, they are discontinuous. They are discontinuous. Rahul, I'll be explaining. Rishabh, I hope you might have understood now. Hmm? Now look here. So we have learned the most important sections of six trigonometric ratios. Now we are going to go to the next topic. Our next topic is, just understand this one. Hereafter we will be playing, see, pi by 2 and pi. Pi by 2 and pi. These are two things. Okay. Pi by 2 and pi. You will be saying, auntie, why you are suddenly started discussing about, I think camera is out of focus or blur. Mm, wow. Yes, it's blur beta. I think something happened. I put this cross. That part is exactly not responding. Now here it is 0. This is beta pi by 2 and this is pi and this is 3 pi by 2. Okay. So now we are going to write, first understand some important contents. After that we will do the next part of the work. But here you just first, for this next class, day after tomorrow, I'll explain that sections. Pi by 2, it is pi minus theta. This is pi plus theta, because from here to here it is acute part, means what? It is less than. So here this will become 3 pi by 2 minus theta, and this is 3 pi by 2 plus theta, and this is 2 pi minus theta, and this is 2 pi plus theta. So I'm going to explain about rotation and everything in the next class. Okay, so bye for now. Thank you so much, Siddharth, Payoja. Here it will become 90 plus theta. Siddharth, Payoja, everyone, thank you so much for being there, and thank you so much for listening me and cooperating in the class. God bless you all. Have a nice day to all of you, beta.